Going to explain using the distributive property with radicals. So example number 1, radical 6 times the rational number 3 simply looks like that. And then multiplying two radicals together, take that product underneath the same radical. It's simply the square root of 48. 48 is 16 times 3. And then you would just simply stop. You don't have like radicands in this example, so you would stop right there. An example like number 2, where you've got a binomial set up times another binomial, just run through the process of distributing. 4 times 2 is 8, and then 4 minus 4 radical 3. Come back to the first binomial and repeat the process. And then here you've got positive radical 3 minus radical 3. So let's just stop for a minute and review. If I have radical 3 times radical 3, that's just the rational number 3. So notice the alternating signs here. This is positive radical 3 times negative radical 3. So the way that the last term in this particular product is going to be minus 3 because of the alternating signs there, the positive, negative. And then you just combine like terms. 8 and 3 combined to give me 5. And then I've got like radicands with radical 3, so I combine negative 4 and positive 2. And the simplified product, that would be my simplified product. Let's do some of the examples in the problem sets. Let's look at number 12. And number 12, notice that I've got 3 radical 10 sitting on the outside. So I'm going to multiply the 3 on the outside times the 5 on the inside, since they are both rational numbers. So that's going to give me 15 radical 10. And then to multiply the second pairing, I'm going to multiply parts that are alike. I'm going to multiply 3 times 4. That's going to give me 12. And then I'm going to multiply radical 10 times radical 2. And that's going to give me radical 20. So notice how I did that. I multiplied the parts that were outside together, and then I multiplied the 2 radicands together underneath a new radical. And now I need to simplify the expression. 15 radical 10 is already as simplified as it can be. 20 has a perfect square of 4. 20 is 4 times 5. The square root of 4 is 2. So I would multiply that by the 12 that's sitting out there, making this 24. And then I would have radical 5 left over. Since the radicands are not the same, I would stop. That would be my end result product for number 12. Let's do another one. Let's do a problem. Let's do 13 and 14 on the video. Okay, so number 13. Notice that I've got negative 2 and positive 3. So I'm going to combine those to give me negative 6. And then underneath the radical, I'm going to have radical 3 times radical 10. That's going to give me radical 30. And then moving on with the process, negative 2 times negative 3, giving me positive 6. And then I'm going to have radical 3 times radical 6, giving me radical 18. So notice how I did that. And now I need to simplify the radicals. Negative 6 radical 30 is already simplified. 30 is just 5 times 6 or 3 times 10. There are no perfect square factors in 30. 18 is 9 times 2, so that's 9 times 2. The square root of 9 is 3, and then multiply that by the 6 that's already sitting out there. And now I analyze. I have radical 30 and radical 2. They're not like radicands, so I would stop right there. That would be my simplified expression for that problem. Let's look at number 14 together. And number 14, well, I've got negative 4, and there, you would think of a 1 being in front of the radical 6, so I don't have to worry about that. So I just simply have negative 4, and then for the radical portion, radical 2 times radical 6, giving me radical 12. And then I would have negative 4 times 3, so that gives me negative 12. And then combining the radical component, I would have 2 times 14 giving me radical 28. And then I need to simplify each radical. So 12 is 4 times 3. 4 is the perfect square. So I would have negative 8 radical 3. And 28 is 4 times 7. 4 being the perfect square. Square root of 4 is 2. So that, multiply that by the 12. And then I stop and I analyze the radicands. The radicands are not the same, so I would simply stop there. Let's do a problem like number 16. 15 and 16 on the video. So a problem like number 15, radical 5 times itself is just the integer 5, basic skill. Radical 5 times 4, and then come back to the first binomial and pick up the second, and then end it with the rational number 2 times the rational number 4, which is just going to be plus 8. And now analyze for combining like terms. 5 and 8 are like terms, and I have like radicands, so I combine 4 and 2, and that would be my simplified product for a problem like number 15. Let's look at number 16. Number 16, I have radical 2 times radical 2, which is just going to be the rational number 2, and then radical 2 times positive 5, and then coming back to the first binomial and picking up the negative 6, and then negative 6 times positive 5, and then analyze to combine like terms. 2 and negative 30 are like terms. Radical 2 and radical 2 are like terms, so I combine the 5 and the negative 6. And this represents my end result product for a problem like that. Number 18, this notation, the squaring, is telling me to take this expression and multiply it times itself. So to follow through with this, 2 times 2 is 4. And then radical 7 times radical 7 is just simply the integer 7. And then I would multiply the first expression by 1. And then I would come back to the first binomial and I would pick up the second. And then I would simply end it with 1 times 1. Then combining like terms, I have 28 plus 1. So that gives me 29. And then I have like radicands with a 7, so I add 2 and 2 together, and I end up with that product.